Lesson: Threat Contextualization Using Natural Language Processing. Threat contextualization using natural language processing has emerged as a vital tool in cybersecurity, particularly within the realms of threat intelligence and threat hunting. As part of the CompTIA CySA Plus certification, understanding the application of NLP in this context is essential for cybersecurity professionals who aim to leverage artificial intelligence to enhance their capabilities. NLP's ability to process and interpret human language allows security teams to sift through vast amounts of unstructured data, providing actionable insights that are crucial for identifying and mitigating potential threats. Cybersecurity threats are increasingly sophisticated and voluminous, often buried in a sea of unstructured data such as emails, social media posts, threat reports, and dark web communications. NLP technologies are instrumental in parsing this data, identifying patterns, and turning seemingly disparate pieces of information into coherent threat intelligence. By applying NLP, professionals can automate the analysis of threat data, thereby reducing the time and effort required to understand and respond to threats. One of the primary benefits of NLP in threat intelligence is its ability to process and analyze large volumes of text data rapidly. Traditional methods of threat analysis often involve manual processes that are time-consuming and prone to human error. NLP technologies, such as named entity recognition and sentiment analysis, can automate these processes. NR, for example, can identify and categorize entities such as IP addresses, malware names, and threat actor aliases within text data, enabling faster and more accurate threat detection. Sentiment analysis can gauge the tone of communications, helping to prioritize threats by assessing the urgency or hostility of a message. Moreover, NLP can enhance threat intelligence by correlating data from multiple sources. Tools like Elasticsearch and Apache Lucene can index and search large sets of text data, allowing analysts to cross-reference information from different threat reports and sources. This capability is crucial in identifying threat vectors that might not be apparent when analyzing data from a single source. For instance, a pattern of malicious activity identified in one region can be cross-referenced with similar activities reported elsewhere, providing a broader context for potential global threats. Practical tools such as IBM Watson and Google's Natural Language API offer robust NLP capabilities that can be integrated into existing cybersecurity frameworks. These platforms provide pre-trained models that can be used to analyze text data for threat intelligence purposes. For example, IBM Watson's NLP capabilities can be used to extract relevant information from threat reports and advisories, identifying key indicators of compromise and other critical data points. Google's Natural Language API, on the other hand, offers sentiment analysis, entity recognition, and syntax analysis, allowing security teams to quickly assess and prioritize threats based on the analysis of textual data. A practical application of NLP in threat intelligence can be seen in the use of NLP for phishing detection. Phishing emails often contain subtle linguistic cues that can be difficult for traditional security systems to detect. NLP models trained to recognize these cues can enhance email security systems by improving their ability to detect and block phishing attempts. For example, an NLP model can be trained to identify phrases commonly used in phishing emails, such as urgent requests for personal information, and flag such emails for further investigation. In addition to threat detection, NLP can be used for threat prediction. By analyzing historical data and identifying trends, NLP can help predict future threats and their potential impact. This predictive capability is valuable for proactive threat hunting, allowing security teams to anticipate and mitigate threats before they materialize. For instance, by analyzing threat actor communications on the dark web, NLP can identify emerging threat patterns and inform security teams about potential attacks on the horizon. The application of NLP in threat contextualization is not without challenges. One significant challenge is the need for large datasets to train NLP models effectively. These datasets must be comprehensive and representative of the types of threats an organization is likely to encounter. Additionally, the dynamic nature of language, with its nuances and ambiguities, poses a challenge for NLP models. which must be continuously updated and refined to maintain their effectiveness. Despite these challenges, the benefits of using NLP for threat intelligence far outweigh the difficulties, especially as the technology continues to evolve and improve. Case studies further illustrate the effectiveness of NLP in threat contextualization. For example, a financial institution used NLP to analyze and categorize threat reports, resulting in a 40% reduction in the time taken to identify and respond to threats. By automating the analysis of threat data, the institution was able to prioritize threats more effectively, focusing its resources on the most critical issues. Similarly, a healthcare organization employed NLP to monitor social media for potential threats, allowing it to identify and mitigate a ransomware attack before it could cause significant damage. In conclusion, threat contextualization using NLP represents a powerful advancement in the field of cybersecurity. By automating the analysis of unstructured data and providing actionable insights, NLP enables security teams to identify, prioritize, and respond to threats more efficiently and effectively. The integration of NLP technologies into threat intelligence and hunting practices is not only beneficial, but essential for organizations seeking to enhance their cybersecurity posture. As NLP tools and frameworks continue to evolve, they will undoubtedly play an increasingly critical role in the ongoing battle against cyber threats.